All right, so this is the review, okay? So this is problem number 1 from the review that I handed out, and you can also access it on Canvas as well, the paper copy. All right, so it says x equals 3t plus 1 and y equals t squared minus 2 and t equals negative 3. This problem is very simple. It just wants us to simply take this negative 3 and plug it in for t there, and then again for t right there, okay? So I'm going to let the calculator do all the hard work for me, okay? So I already know that t is negative 3, so I'm going to say for x, I'm doing the x equals 3 times negative 3, so I'm just replacing t with negative 3, plus 1. Oh, I missed my plus 1. Plus 1. Wham, bam. It's negative 8. So x is equal to negative 8. Okay? And then the y equals is just t squared minus 2, so I'm going to let the calculator do the thing for me again. Now, I do put that negative 3, in the parentheses, and then I put the square on the outside of the parentheses, and then I say minus 2, and I get 7. So I know that y equals 7. So I know that y is equal to 7. And there you go. That's all it's looking for, okay? All right, next one. Same idea, just different problem. X is equal to the square root of t minus 2. Y is equal to 3. Y is equal to 3 minus 3t, and t equals 6. So you plug in the 6, so you get x equals the square root of 6 minus 2. Well, I mean, I don't really need my calculator here, because I know that if I plug in a 6 minus 2, it's minus, not times. I know that square root of 6 minus 2, well, that's just the square root of 4. And I know that the square root of 4 is just simply 2. So bam, there you go. Same thing over here. You know, you can use the calculator, but if you know basic, addition and subtraction, then you should really be okay. 3 minus 3 times 6. Well, I know that 3 times 6 is 18. 3 minus 18 is just negative 15. So there you go. X equals 2. Y equals negative 15. Next problem. Sketch a graph of the parametric equations. We talked about this in all of our classes. Okay, but in case you're super off on it, the calculator can do this hard work for me. This is parametric, so I need to be in parametric mode. I'm already there. So I go back to y equals 2t minus 1. And then I need to do t squared plus 3. I click graph. And that's half a parabola, quite obviously, especially since it says y equals t squared. That's quadratic. So I know then that, it's just going to be a parabola. And that's really what the test is looking for, the ability for you to identify what the shape is. All right. Number 4, same idea. Y equals 4 cosine t. And then just simply sine t. I hit graph. And bam, that is clearly an ellipse. Because remember, a circle is equidistant from its center. All the points are equidistant from the center. An ellipse that is not true on. If you hit zoom 5, that squares up the window so you can see it a little bit better. You still see that it's not a circle. Okay? So it is an ellipse. All right? Number 5. X equals t plus 2, y equals t squared. What this problem is asking for you to do is to eliminate the parameter. So to eliminate the parameter simply means that you want to get an equation where there's no t. You want to get an equation that just has x and y. So if x is equal to t plus 2, then I can say x minus 2 is equal to t. And if I know that x minus 2 is equal to t, then I know when y is equal to t squared, I can say y is equal to x minus 2 squared. Let's see if I can't find that square again. Whoop, I clicked the wrong button. Squared. Okay. And then the test is going to expect that you do something like this. Y is equal to x minus 2 times x minus 2. And then it's going to expect you to multiply it out. So that would be first times first. So x times x, which would be x squared. Okay. And then you're going to do first times second, x times negative 2, which is negative 2x. Then second times first, which again is another negative 2x, and then a positive 4. And then I put like terms together, so I get y is equal to x squared minus 4x plus 4. There you go. That's what the test is going to look like, that answer right there. See how I have an equation that has no t, only x and y? That means I eliminated the parameter. All right, let's go to the next one. X is equal to t over 2, y is equal to 1 over t. So once again, I want to eliminate the parameters. So that means I need to solve for t on the x equation and then plug that in for the y equation. So then 2x is equal to t. Okay, so all I did was multiply both sides by 2 because it was t divided by 2. Okay, and t divided by 2 to get t by itself, you just multiply by 2. And this says y is equal to 1 over t, so I know that's going to be y is equal to 1 over, well, t is the same thing as 2x, so I could just say 2x. And there you go. I mean, I solved for t, I plugged in what I solved for t, and it was done. It was simplified. Now, if I need to simplify it further, I would. Okay? Number 7. Convert the rectangular equation y equals x over x minus 1 to a parametric equation using t equals x minus 1 as the parameter. So whenever you have a rectangular and you want to change it to a parametric, what you have to do is create two equations, both an x equation and a y equation, involving t. Okay, so we need x equals something t and y equals something t. Well, what do we know about t? We know that t is equal to x minus 1. Is there a way I could rearrange this so it said x equals? Yeah, I could just simply add 1 to both sides. And if I did that, I would get t plus 1 is equal to x. Okay, so then up here, I could just simply write t plus 1. Sorry, my writing's really bad on this thing. Okay, and then it says y equals. So I need to rearrange this y so that it just had t's. Well, what do I know x is? T plus 1. And I have an x and an x. If I replace these x's, I'll have t's. So y equals t plus 1. So all I did was change this x right here to being t plus 1, because I know x equals that, divided by x minus 1. And x is equal to t plus 1. So I'll just simply say t plus 1 minus 1. And then you notice that this positive 1 and this negative 1 can cancel each other out. So you're going to get t plus 1 all divided by t. And that's what y will equal. And there we are. Okay, so those are my two answers. Alright, next problem here. Same idea. Convert the rectangular equation. Okay, so we have convert the rectangular equation y equals 1 to... Okay, so number 8. Convert the rectangular equation y equals 1 over 4x to parametric equations using t is equal to 4x as the parameter. Alright, so once again, we want to get two equations. One where it's x equals something t, and one where it's y equals something t. We know that t is equal to 4x. So I can solve for x by dividing by 4 on both sides. Okay, that's a 4, not a y. Alright, so we have t over 4 is equal to x. So I can go and write that over there. So t over 4. Now, we have an equation for y. Y is equal to 1 over 4x. But I don't want y and x together anymore. I want y and t together. Well, I can replace x with t over 4. So I can say y equals 1 over 4. And instead of x, I'm now going to put t over 4. T over 4. Okay? Now, when you're multiplying a whole number and a fraction, the whole number multiplies to the top. And it allows me to cancel it out with a denominator. So I'm just going to get 1 over t. So y is equal to 1 over t. Awesome. Next problem. Problem number 9. Consider, for 9 and 10, consider a projectile launched at the height of h feet above the ground at an angle of theta degrees with a horizontal. The initial velocity v naught is in feet per second, and the path of the projectile is modeled by the pair of parametric equations. X is equal to v naught cosine theta t, and y is equal to h plus v naught sine theta t minus 16t squared. A dart is thrown from a point 5 feet above the ground with an initial velocity of 58 feet per second at an angle of elevation of 41 degrees. Find parametric equations that model the problem situation. Okay, well, we already know what x equals. X equals v naught cosine theta t. Well, what is v naught? V naught is my initial velocity. In this case, that's 58. Cosine of theta. Now, theta for this problem is 41 degrees. So we're just going to put, oh, no, come back. 41 times t. There's my x equals equation. Now, my y equals equation is just simply y equals h. That means starting height. And it tells me the dart was thrown 5 feet above the ground, so 5 plus v naught which in this case is 58, sine 41 times t minus 16t squared. There I go. That's all it wants. It just wants the two parametric equations. So really, you're just plugging in, and that's it. That's all you're trying to do. All right. Next problem. A baseball is hit at a point 3 feet above the ground. The center field is 7 feet tall at 408 feet away from the batter. The baseball leaves the bat at an angle of theta degrees with the horizontal at a speed of 100 miles per hour. Write a set of parametric equations that model the path of the baseball, knowing that 1 mile per hour is 1.467 feet per second. Okay, so first off, we see that my initial velocity is 100, but then they give us this information. They want us to change 100 miles per hour into being feet per second. Okay, now, you need to realize that 1 mile per hour is 1.467 feet per second, okay? So, if I have 100 miles, then the baseball is traveling at 146.7 feet per second, okay? And you can find that just by simply multiplying. If you know you're going 100 miles an hour, so that's let me turn this on. Sorry, sometimes it's really persnickety. There it goes. Okay. So 100 times 1.467 is 146.7. So our initial velocity, we're going to say, is 146.7 feet per second. Okay? So we're going to write both of our equations under that idea. All right? So again, x is equal to v naught, which is 146.7 feet per second, times cosine of the angle, which in this case, it leaves it at just theta. All right? Just leaves it at theta. So you'll just plug in theta. It doesn't give us an angle. Just trying to make sure it doesn't give us an angle. Yeah. So you're just going to leave it at theta. Theta times t. All right. Now, more than likely on the test, they're actually going to give you what theta is. But on this one, we just want to see if you guys could realize that we didn't give you theta. All right. So h, which is my initial height. So the baseball was hit at a height of 3 feet, plus initial velocity once again, which is 146.7, sine of theta times t minus 16t squared. Oop, that's not the right one. Other. And there you go. Those are your two parametric equations. That's all you need. Okay? All right. That's going to end it for this video. I'm going to pick up in the next video on problem 11. Okay?